pleasure to introduce Alexandre Declos, I think I'm saying that right, to talk to us about virtual properties and their troubles. Take it away, Alexandre.
Thanks a lot, Neil. So first of all, I want to say that I'm very happy to be here. So yeah, how do I make you disappear? Would you know that? Sorry, I'm not so good.
I don't think so. I don't know really. Normally, I just when I go full screen, I still get the full
like
showing.
That. Yeah. Okay. So I hope that the screen will still display properly. Okay. So yeah, in this talk, I'm gonna talk about virtual properties and some of the troubles that they may face. So let me get started by saying that it seems very natural at first glance to say that virtual reality and augmented reality environments contain various objects which possess properties and which enter into different relations. But the immediate issue, of course, is to know if we can unproblematically extend our ordinary talk of objects, properties, and relations to VR and AR. After all, what are these virtual objects which we represent as having properties or as entering into relations? Should we even say that virtual objects possess any properties at all? And if so, should we put their properties or relations on par with the property and relations of non-virtual objects? So these are the issues that I want to address here. So here's the outline of the talk. I'll start by considering the theory of virtual properties, which was proposed by David Chalmers. After that, I'll discuss 4 objections to virtual properties. And lastly, I'll turn to virtual properties in the specific case of AR. So first, some general comments on virtual properties. So VR and AR spaces are populated by virtual objects, such as virtual cats, virtual tables, and so on. And I propose to call these things quite generically virtualia. Of course, in order to say what properties virtual objects can have, if they can have any properties at all, we need to say a bit more about their nature. And here, as we know, there are 2 rival accounts in the literature. One of them is virtual fictionalism, and the other is virtual realism. So in this talk, I'm going to focus on virtual realism for several reasons. One of them being that virtual fictionalists don't have much to say about properties because they will admit that the props which support games of make-believe have properties, but they won't introduce anything like virtual properties at all because they just think that virtual objects don't exist. So virtual realism is more interesting on this score, and that's why I'll focus on this view here. So virtual realism, as championed by Chalmers, is a complex view, but if we focus on its ontological claims or components, they are the following. First, virtual objects are real digital objects. And second, events in virtual worlds are digital events that really take place, involving virtual properties that are really instantiated. So the core claims here are that virtual objects are real, that they have genuine properties, and that these properties are virtual properties of a specific kind. Now, of course, the main question, at least for me here, is to know what are these sui generis virtual properties. So let's try to see how Chalmers actually introduced this notion. Properties initially come as troublemakers for Chalmers' digitalism, namely the view that virtual objects are digital entities, such as data structures or arrays of bits and so on. Take the following argument. So we assume that's digitalism, that any virtual entity X is a digital entity Y. If we manage to show that there is a property that X and Y don't have in common, we can conclude that X and Y cannot be identical, so against digitalism. And Chalmers actually envisions a case which would support the second premise. And this case is the following. So take a virtual tomato, which you see in your VR headset. It is red, but the corresponding data structure, of course, does not have this property, right? Like you cannot see the data structure at all, and even if you could, it probably wouldn't be red. So that's why there's a worry here for digitalism. Chalmers actually proposed to solve the issue as follows. it differentiates between non-virtual redness and virtual redness. Non-virtual redness is that which produces reddish experiences in normal conditions for ordinary human perception, whereas virtual redness is that which produces reddish experiences in normal conditions for VR. So when you have a headset on and so on and so forth. With this distinction, we can now say that although the data structure is not red in the ordinary sense, it is virtually red. So if we assume digitalism, the virtual tomato is virtually red too, and the previous problem is therefore avoided. Actually, Chalmers is willing to extend this analysis to spatial properties. So he's going to say, for instance, that the billiard ball that you see in your VR headset is virtually round and virtually 10 centimeters tall. Why? Well, because it produces a roundish experience and a 10 centimeters tallish experience in normal VR settings. So more generally, we could differentiate between ordinary fness and virtual fness as follows. Ordinary fness is that which produces f-ish experiences in normal conditions for human perception, while virtual fness is that which produces f-ish experiences in normal conditions for VR. So to a first approximation, Chalmers' view is the following. X instantiates virtual fness if and only if, when X is perceived in normal conditions for VR, X produces a f-ish experience. Okay, now I have a number of comments to make on this account. The first comment is that this is a functionalist theory. Why? Because it characterizes properties in terms of their functional or causal role. And I think that just like other functionalist accounts, this kind of view can easily explain the phenomenon of multiple realizability. And in this case, the multiple realizability of virtual properties. So if you play two VR games such as Beat Saber and Skyrim VR, you're going to have different data structures for the red objects that you see, but these data structures still correspond to a same functional role. Therefore, there are different realizations of the same virtual property. And I think that this is an attractive claim. Another remark is that Chalmers accepts, I think, what I would call a principle of correlation, according to which every ordinary property has a correlate virtual property. As he writes, for any property X, there will be a corresponding virtual property virtual X. When a non-virtual object has X, the corresponding virtual object will have virtual X. So what the principle of correlation does is that it yields a mirror virtual image for each ordinary property. And the same would presumably go for relations. A third remark is that Chalmers is committed, I think, to a kind of property dualism, because virtual objects will have two kinds of properties. As digital objects, they'll have ordinary or non-virtual properties, such as non-virtual spatial temporal location or non-virtual causal powers. But on the other hand, as virtual objects perceived in our headsets, they'll have virtual properties, virtual colors, virtual shape, virtual location, etc. So a virtual object has virtual and non-virtual properties, which are taken to be different sorts of properties. And that's why I think this is a kind of dualism. Another important remark is that virtual properties exist only relatively. So let me explain. If you take a VR app A, in which you see a red tomato, and a VR app B, in which you see a pink banana, it's clear that A users won't see anything virtually pink. And that if B is blown out of existence, the virtual banana would cease to exist. So virtual properties are only instantiated and exist relatively to given VR apps or particular virtual spaces. This means that we should specify the previous definition as follows. X instantiates virtual fness in a virtual environment E, if and only if, when perceived in normal conditions for VR environment E, it produces a f-ish experience. A last remark is the following. So Alice Annay has objected to Chalmers that virtual spatial properties cannot be analyzed in phenomenal terms. I won't go into the details of the discussion here, but I just want to note that Chalmers replied that functional and causal roles need not necessarily be correlated with particular phenomenal experiences. So Chalmers writes, for instance, that a virtual object is virtually solid when it is rigid and resists penetration. So as you see here, there is no mention of any kind of phenomenal experience. So if that's right, we can therefore suggest that the virtual property can also be characterized through a non-phenomenal functional role. This for this, we need to amend the previous definition as follows. X instantiate virtual fness in an environment E when, if and only if, when X is perceived in normal conditions for this environment, X produces a fish experience, or, and that's the new clause, in this environment, X has the causal or functional role associated to non-virtual fness. So I think that's how we could get away with Ney's objection. Okay. All this being said, I'm not gonna. I am going to turn now to a few objections to virtual properties, and I should mention that these objections haven't been discussed directly by Chalmers, and my goal will be to try to show how we could answer them. So the first objection is about the scope of the theory of virtual properties. First, we could wonder if it applies to virtual sorts. So if you see a virtual red apple in your VR headset, Chalmers is going to say that you see virtual redness, and virtual redness is whatever brings about reddish experiences in VR settings. But when you see the virtual red apple, you also see something which has the property of being an apple. And what is this property of virtual applehood, we may ask? Well, by parity of reasoning, we should perhaps say that it is whatever brings about an apple-ish experience in normal VR settings. But of course, if you see a virtual apple, you also see something which has the property of being a virtual object. And what is this property of virtual objecthood? Well, it is whatever brings about an object-ish experience in normal VR settings. Or at least it seems that Chalmers should say something like that. And you see where I'm going. It seems a bit odd, and it's quite unclear whether we can accommodate sortal properties. So properties which denote sorts or kinds of entities like that. Another question is to know if we should accept virtual higher order properties. Can a virtual color have the higher order virtual property of being a primary color? And if so, should we say that this is a matter of bringing about a primary colorish experience in normal VR settings? Again, this is quite uncertain. Lastly, Chalmers did not actually say much on this, but of course, we need to account for relations. So if you see a dog attacking a cat in VR, should you say that what you see are virtual objects interacting in such a way that they bring about a catish experience, a dogish experience, and a dog attacking catish experience? This seems odd again. So the worry here is what I called earlier the principle of correlation. Should the virtual realist accept any virtual property or relation whatsoever? And in fact, can every property or relation be analyzed in functional terms? The issue here is not just that the paraphrase will be complex or awkward in some cases. It is that we can doubt that there's a distinctive type of phenomenal experience associated to each candidate virtual property or relation. So that was the first objection. I think that there are several possibilities to tackle it. The first option would be to deny that some of the previous examples that I've discussed represent genuine properties. And in that case, we wouldn't need to worry about their virtual correlates. So if you deny that there is such a thing, for instance, as being the property of being a primary color, you don't have to worry about the virtual property of being a primary color. I think that this is quite a cheap way out, though, because obviously it won't generalize. And in particular, I don't see how it could generalize to relations. It seems very difficult to eliminate relations altogether, right? So there is another, and I think better option, which is to accept Chalmers' analysis for shapes, colors, these kind of properties, but to provide another story for other type of virtual properties. For instance, we could propose that virtual sorts are to be analyzed with a theory of object recognition and say that X is a virtual cat if it is recognized by users as a cat-like entity in normal conditions for VR. I think this is better, but again, I don't see how this move could generalize. I mean, we need to provide a different story for many other types of properties. So that's a question mark again. So perhaps the best bet would be to move to non-phenomenal functional roles. We could say, for instance, that the solo property of being a virtual door corresponds to a particular functional role, which is that of being a movable barrier that allows entry or exit from an enclosure. And as you see here, no reference is made to a doorish experience. So the previous issue disappears. Okay, let's now consider another objection. Virtual Fness, according to Chalmers, is what generates F-ish experiences or what plays the F role in normal conditions for VR. You see this clause in blue, and it's very important. But we could wonder why this clause about viewing conditions makes an ontological difference. Or in other words, why it would make us experience virtual redness rather than non-virtual redness. According to Guillaume Schupert, this is because Chalmers endorses the following principle, which he dubs the ontological innovation principle. It reads like this: for any X and any P such that X isn't P, if X depends on technology T and X brings about P-ish experiences in circumstances which are normal for T, then there's a special property PT corresponding to P and X is PT. So I think that actually, yeah, it seems that Chalmers is using a principle of the sort to introduce virtual redness. But if that's so, Schupert goes on to argue, we're going to have a problem because this principle will lead to a proliferation of sui generis property types. So here's an example. A film roll is not red in the ordinary sense if you hold it in your hands, but it will produce reddish experiences in normal film settings, meaning when the roll is plugged into a working projector, aimed at a widescreen, and so on and so forth. By the ontological innovation principle, it follows that the film roll, although it's not ordinarily red, is filmically red in its own filmic and spatial fashion. So the problem is this. Chalmers' argument for introducing virtual properties would lead, by the very same reasoning, to the admission of filmic properties, and so on for other technological media. I think that there are several possibilities to answer this objection. The first is to say that, as stated, the principle that Schupert uses implies that each particular VR device will yield a different type of virtual property. So, for instance, we'll have HTC Vive virtual properties and Oculus Rift virtual properties. But surely, no one needs to accept this. So it shows that the principle, as stated, is wrong. Second, I'd say that the analogy between VR and film is fragile, because in traditional movies, there's a photographic process. The stills track the ordinary properties of the recorded entities. So if you watch the first Star Wars movies, when you see Vader's like helmet being black, what you see is a property of blackness that you would have seen if you had been present when the movie was shot. But by contrast, VR is computer generated. There is no photographic process going on here. So no ordinary properties of independently existing entities are being tracked. If that's right, we could argue that we don't need to introduce anything such as special filmic properties against what Schupert claims. Now, of course, Schupert is probably going to say, but what about fully digital movies in which there's no photographic process at all? So if you take Toy Story, you have this green dinosaur named Rex. And Rex, of course, did not walk into a studio for being recorded. So should we say here that Rex has a special filmic greenness? I don't think so, because the ontological innovation principle doesn't apply here. The principle starts like this, let's recall, for any X and any P such that X isn't P. But I think we can stop here and say, okay, Rex is green. It's just a picture with ordinary non-virtual color properties. So if that's right, we can answer Schupert's objection. Let me now turn to a third issue. we could imagine a situation like the following. Suppose a virtual tomato and a non-virtual stop sign producing two reddish experiences in someone such that this person cannot tell the colors apart. This person, quite naturally, will think that these are experiences of the same color property. But charmers cannot say that. Why? Well, because the stop sign is non-virtually red, whereas the apple is virtually red. These are different rednesses. So the person is mistaken when she thinks that she experiences, in the two cases, the same color property. So Schubert goes on to say that Chalmers is therefore led to ascribe massive mistakes to VR and AR users, however sophisticated they are. It would be deeply mistaken, for instance, when you're using an AR app to compare the virtual and non-virtual colors of the objects that you are seeing. Now, I think that this objection can be dealt with. Chalmers, as you know, contends that sophisticated VR users do come to perceive virtual objects as virtual. And he suggests that the same might hold true for virtual properties. As he writes, I'm inclined to say that the sophisticated user may see objects as having virtual colors, though perhaps this is not as straightforward as the case of perceiving virtual space. Now, the question, of course, is to know what it is to perceive a virtual color as virtual, or in other words, what is the distinctive phenomenology of virtual properties. I think that we could say something like this. To perceive a redness as virtual might involve certain beliefs or dispositions. For instance, the belief that this color appearance is produced by an array of pixels lighting up, or the belief that this color appearance could be changed at the whim of the programmer, say. It could also involve a disposition, such as a disposition to adjust the brightness of your screen, of the headset, if you have a headache. So if sophisticated VR and AR users can perceive virtual properties as virtual, they won't conflate them with non-virtual properties, and so will make no errors. I think this is a way to avoid Schubert's objection. Finally, let me discuss the last issue. You've heard of adverbialism, which is the view that perception is a modification of experience. So, for instance, to perceive something red and round is to perceive redly and roundly. Frank Jackson has raised an objection to this view, which is known as the many property problem. The objection is the following. Suppose that S perceives a red circle and a blue square. Adverbialists will say that this should be analyzed like this. S senses roundly and redly and squarely and bluely. But now, if you suppose that S perceives a blue circle and a red square, adverbialists will say that this is a case where S senses roundly and bluely and squarely and redly. But since conjunction is commutative, meaning that you can freely swap the order of conjuncts within a given sentence, we get the result that 1 is the same as 2, which is absurd because the two visual scenes are obviously different. So adverbialism cannot account for this difference. That's Jackson's objection. Manuel Rebucci proposes that this issue actually extends to Chalmers' account of virtual properties. So if you take a VR scene 1 in which you see a virtual red circle and a virtual blue square, we could say that this scene brings about a reddish and roundish and bluish and squarish experience in normal VR settings. But now, a VR scene 2 in which you see a virtual blue circle and a virtual red square is such that it brings about a roundish and bluish and reddish and squarish experience in normal VR settings. So again, we could object the same thing. There is no difference here. Chalmers cannot explain how the two visual scenes differ. So he's facing the many property problem, just like adverbialists do. I think that this objection is misguided because virtual properties don't float free. The properties exemplified in the two scenes are the same, but the property bearers are different. If that's right, we can differentiate the two scenes. We can say that in the first VR scene, we have a virtual square, which is virtually blue, and a virtual circle, which is virtually red. Whereas in the scene number 2, we have a virtual square, which is virtually red, and a virtual circle, which is virtually blue. It should be noted, though, that for this reply to work, being a virtual square or being a virtual circle cannot be virtual properties. Otherwise, the issue will resurface. So overall, my suggestion is that to avoid the many property problem, we can construe virtual sorts as virtual properties, or at least we have to admit virtual objects or property bearers besides virtual properties. We could say that Chalmers cannot be a bundle theorist for virtual properties. Okay, so in the remaining time, I'm going to discuss the case of virtual properties in the specific case of augmented reality. What can the virtual realist say about properties in AR? At first glance, it might seem that AR does not show anything special on this score because the properties involved here will simply be a mix of non-virtual and virtual properties. So AR wouldn't bring anything interesting on the table. I think that this impression is mistaken and that there are a number of interesting things about properties in AR settings. The first is that in AR, say my non-virtual car can be repainted in virtual red with a certain app, but it can also be repainted in virtual pink with another app at the very same time. To avoid contradiction, we must say here that these virtual color properties are instantiated in distinct AR spaces. So what AR reveals is that the same non-virtual object can have different virtual properties across AR environment. And I think that's an interesting observation. But now you could ask about a case where we would use the same app. So suppose that we are using the same AR device and software at the same location. Imagine that I reskin everything in pink, but that you recolor everything in black and white. Here, if we want to avoid assigning incompatible virtual properties to the non-virtual objects found here, we have to say that what we are perceiving are different AR spaces, even though we are using the same app. So what I mean is that in that case, the non-virtual tree is virtually pink in my AR space, while it's virtually gray in your AR space. But if we say that, opens a threat of what I would call AR solipsism. With such customizations, different users might never perceive exactly the same AR environment. Doesn't this mean that they would end up inhabiting their own private AR world? I don't think we should worry too much about that. First, because the non-virtual layer will remain the same across AR users. So this somehow deflates the risk of a genuine solipsism. Secondly, an AR app corresponds to a bunch of functionalities or a collection of AR spaces within which users navigate freely. This means I think that users could easily switch to an environment that would be fitting that the one that their interlocutor is perceiving, if needed. At any rate, the claim that each AR user typically perceives their own AR space seems quite intuitive, although it's not with VR. In this particular respect, I think that AR is actually more insulating than VR, contrarily to what is often said. Now, another interesting thing is that AR shows that instantiation is cross-modal. So my car is black in physical reality, but it can be virtually pink in a given AR space. But this isn't a problem though, because the property types are different here. My car is non-virtually black, but it is virtually pink. And these property types are being instantiated in different spaces, so that's okay. If that's right, AR shows that property instantiation is cross-modal in this sense. A non-virtual X can instantiate both virtual and non-virtual properties. I think that AR even shows that X can instantiate incompatible pairs of virtual and non-virtual properties. So for instance, non-virtual redness and virtual blueness. And I think that this is a quite remarkable metaphysical fact, and that AR is actually bringing something really new on the table here. As a last remark, I'd like to mention something about AR properties and persistence. So compare the two following sentences. One, the non-virtual car gains the property of being virtually red in this AR environment. And two, the non-virtual car gains the property of being a virtual pancake in this AR environment. Intuitively, the first sentence seems true, but not the second. And of course, we could wonder why. I suggest that this is because in the first sentence, identity is preserved to property change. So a car, virtual or not, can survive a change of color, virtual or not. But in the second case, identity isn't preserved because a car, virtual or not, cannot become a pancake, virtual or not. So the second case really is a case of occlusion, where my car is still out there in physical space, but is being occluded by a virtual object in the AR space. So what I wanted to show with this example is that AR presses us to clarify the persistence condition of non-virtual objects within AR spaces. We need to decide which virtual property changes are going to be identity preserving. As a conclusion, I've stressed here that virtual properties are a core component of virtual realism, and that although this theory of virtual property faces several issues, these can be dealt with. Also, if we accept virtual realism, AR reveals a number of interesting things about properties. First, that instantiation is cross-modal. Second, that the same non-virtual object can have different or even incompatible virtual properties across AR spaces. Third, that the same non-virtual object can have incompatible pairs of virtual and non-virtual properties. And lastly, that AR also reveals a number of issues about the persistent conditions of non-virtual objects, issues which have yet to be clarified. And I'll stop here. Thank you.
Thank you very much, Alexandre. Thank you. And yes, Dr. Machine, thanks a million. Okay, same as before for questions, please. If you can post a Q to me privately for a question and an F for a follow-up. And we'll go to the previously frustrated Fiona for our first question.
Thanks, I enjoyed your talk so much. Thank you so much for such an interesting set of considerations. That was absolutely fantastic. So I liked some of the strategies you used, which was to think about VR and then think about AR cases and whether you face the same problems or different problems. And I suppose I want to press you on one of the things you said about the, I'm just trying to pull up your slides here. Let me find this, sorry, give me a second. Yeah, so it was issue 3 about sophisticated virtual reality users can come to perceive virtual objects as virtual objects and can perhaps come to see virtual properties as virtual properties. And I have a really hard time with that one. And I like your suggestion that if that happens, it's probably because people's beliefs about the situation kick in and so on. But when we move to consider the AR situation as opposed to the VR situation, it just seems to me to become far less plausible that people will be able to tell or see or experience the virtual as virtual and the real as real. Because if you're looking at an object, a purported object or purported property, if you're in AR, you may have absolutely no idea whether it's a real object or a virtual object or a real property or a virtual property, because you don't know the setup of the situation. Whereas in VR, you tend to think, well, you've got the headset on, you know you've entered VR, you know the colors are all funny, you know what it looks like and so on. So it just seems like AR presents more problems for that kind of view.
Yeah, thanks. That's a great point. I would certainly agree with that. And I think that's why also this has been brought up in previous workshops. Perhaps we should actually put borders on virtual objects in AR, right? Because we have much more risk to conflate virtual objects and non-virtual objects, and likewise virtual properties and non-virtual properties. And this could be in some situations, awkward or perhaps even dangerous. So you're right that this reply is going to be much less convincing here. So perhaps like the retreat is to just say, okay, well, in AR, even sophisticated users are going to make mistakes, and this generalizes, but VR is still safe. But that's not satisfactory. So I don't know, I would tend to say that in that case, it is, programmers have actually to make clear whether a property is virtual or not. And if they don't, well, we're going to have problems.
I guess the problem then is if they do, suppose virtual red things pulse or glow or something like that, then it's not going to look red, it's going to look pulsing red, not red. And I suppose maybe just one last thing to say is that in the VR case, it's interesting to try and describe how red might come to look different, even if those beliefs are in play, that it's virtual. I mean, I just can't see how it could really change the phenomenology. Like the stuff's still going to look red. So I just struggle with how things are going to come to look, even if you allow that your beliefs can affect your experiences in general, which I'm quite happy to allow.
Yeah. Well, I think that the difference is not going to be on any kind of phenomenal, like, like the qualitative aspect of the content, because clearly like the color can be looking just the same, whether virtual or not. So we're going to have to plug in beliefs or, as you mentioned, something external to the qualitative content itself. Yeah.
Are you distinguishing between phenomenal content and qualitative content?
Yeah, maybe that would be clear. So I would just say the difference is not going to be on the qualitative content. We have to bring in some beliefs or disposition or something else besides what the qualitative content of what is being presented.
So I guess I don't think that's true. So I guess you could have a view where you have, like, phenomenally it looks the same and then you just have a certain belief. But some people think that if you have a certain belief, it actually changes how things look to you.
Right. Yeah.
And I guess
okay.
I don't find that.
Yeah, I see the point. So I have to work much more on this topic, certainly. But thanks. I mean, that's a great point. And actually, when I started the talk, I was certain that most of these objections weren't going through. And as I started working more and more, I was realizing, yeah, but there is this and that, and there are sub-objections, sub-replies. So here, certainly, this weakens, I think, my reply to this particular objection. So thanks, Fiona.
Thank you very much.
Super. Next question is from Chris.
Sorry, I was taking a second to unmute. Thanks for this, Alex. This might be a small kind of thought, but I'm kind of curious how far it can go. So when you're talking about the cat properties, like the sortal properties, my inclination is to think that looking for functional role is like not really the right direction, but we should be thinking about more like authorial intent. So when I think about like, not thinking about virtual reality, but just like a cartoon of Garfield, like what makes that a cat as opposed to a monster or whatnot, or a demon? It's just that the artist intended that it be a cat. And so I kind of think like if you're in a virtual environment, what makes something a cat or a robot or a virtual dragon or whatever has not to do with how it looks or its functional role, but just with what the programmer intended it to be. And I even think with maybe with walls, like that's true too. So, whether it serves that functional role partially depends on what I can do in the virtual world. So if I have like magic, I'm in a game where there's magic and one of my spells is to walk through walls and I can just do that all the time. They're not serving the function of being the barrier, but that's because I got the power. But they're still intended to be walls by the programmer. And so I'm just kind of wondering, if we're thinking of these things as like fictional objects, then maybe we should also be looking for authorial intent in a lot more cases than we were doing. That's the thought.
Yeah, thanks for the remark. I hadn't actually considered this. So immediately, what I wouldn't like about this proposal is that I can perfectly imagine something that plays the part of a virtual role without the correct authorial intent. So if the software is bugged or if the developer is simply not very good, there might be a part of the environment that's gonna actually act as a wall without the corresponding intent. So I feel that in such cases, we're gonna have an issue. And I actually like a lot the little thing I mentioned at some point about object recognition. I think that users are more likely to say that something is a virtual wall if they recognize it as a wall, independently of what the author wanted. But I think that's certainly a possible view. I mean, what you are presenting, and has to be seen if it can perhaps survive some objection or deal with some cases better than this theory of object recognition, which I mentioned, without, of course, developing it, because that would be a full other project. But yeah, so thanks.
Super. Next question, Dave.
Yeah, thanks, Alex, for this really rich paper. And yeah, thank you so much for giving such great replies to all these objections on my behalf. Many of them before I knew they actually existed. I don't think I know these. Is it the two papers you mentioned, Schubert and
Rebuchy, they're actually in French, so that's probably why. Yeah.
Ah, cool. Is there any chance I can get copies from you and then run them through Google Translate or something when my French is?
I'll send them to you. And actually, I think I've put the references in the slides at the very end.
Okay, fantastic. Yeah, I mean, I've got to think about some of these, a number of these objections, but for the most part, I think, very sympathetic with the replies you made on my behalf, and they seem to be plausible things to say. I think maybe one thing worth saying is, I wasn't really planning to give intending to give any general schema for the relationship between X and virtual X. I mean, I told a story that I think works for colors, which are these very distinctive properties, and that redness might go along with producing certain kinds of experiences in VR normal environment, and maybe that'll work for certain kinds of, especially for properties which look a bit response dependent in the actual world, or concepts or contents that look so response dependent. But I certainly wouldn't intend that as any kind of general story. I mean, some of the time being a virtual X is roughly the same as being an X, or at least a version of X that's relevant in virtual environments. I mean, consciousness, causation, being an object, I'm not really inclined to say there's necessarily fundamentally two distinct properties there. And for other cases, virtual apple, you mentioned, virtual cat, I don't know. I think in some of these cases, it's just a lot of different virtual properties. I mean, what different properties of virtual objects? What does it take to be a virtual cat anyway? Do we count anything that looks like a cat as a virtual cat? Well, that seems more an analog, not of actually being a cat in the physical world. But like this would be a sense in which a robot cat might qualify as being cat-like in the physical world. So do you just require superficial appearances of a cat, or something like many of the underlying organismic properties of being a cat? Anyway, this is just to say that I wasn't intending to offer a totally general account of what it is to be a virtual X for all X, but just to hope that these could be given account in some cases, and to make the case that these would in general be properties that could be plausibly predicated of digital objects. I mean, augmented reality is also super interesting here, and that I take the point about the skinning case is really interesting. We all have different skins. I guess I'm inclined to think that the more we use augmented reality and the more there are multiple systems and multiple skins, the more we will tend to relativize in practice. We're just going to say something like, pink for me, or if we all just use, if there's like 3 different systems that we all use, and like there's the Meta system and the Google system and the Apple system, then maybe we'll just relativize to that. But if all the people who are using the Google system also end up relativizing to skins, then maybe that language will end up entering that kind of parlance will end up entering our common language as well. So I think some degree of relativization of virtual properties is more or less inevitable here. It's really interesting how it's going to apply to virtual objects. I love your car pancake case. I'm a little bit tempted to say that there is just one underlying object there with weird virtual properties, but there's got to be a point where that gives out, and maybe we're all going to have different points where that gives out. But anyway, thanks so much.
Thanks, David, for these comments. I'm just like, the suggestion about linguistic practice, which might change with AR, is really interesting, and I hadn't considered this for the principle of correlation, or the idea that there would be a corresponding virtual property for any ordinary property. I think that it's going to be difficult to try to define virtual cats purely in terms of virtual properties. That's what I was saying about the Jackson argument, because if you make virtual objects bundles of virtual properties, you're going to face the many property problems. So you're going to have something like virtual substrata or virtual substances. And this
I definitely want virtual objects. I want real objects there, which I think are digital objects for sure.
Yeah,
Definitely not just bundles.
yeah. So I think that's actually very interesting because it shows that we need to have a separate argument for introducing virtual objects. And I think, of course, you've said lots about this, but I think this is not something that has been really made clear in the discussions, surrounding virtual realism. So we cannot have just virtual properties. That's all I wanted to stress. Yeah.
Super. So I had one kind of question. I think this is clarificatory because where I thought a particular piece of your presentation was going, it didn't get there. So I want to hear what you think about it. So it's the bit about Schubert talking about ontological innovation and defining the property by the technology, right? So the PT. And one of the cases that Nathan and I discussed in our first paper on this topic was about cross-play problem, as we called it, where what you have is two people both in virtual reality, but just on very different systems, right? So one on a Oculus, the other on a Vive. You might imagine one running from PC and one from Mac. Really very different architecture to our mind, different digital objects. Dave has a thing about abstracting them that is supposed to avoid this kind of problem. But where I thought you were going with this was like you were going to tell us something about what we should say about cases like that, but you didn't. What I think you were doing there dialectically was saying Schubert says, look, this is going to lead to excessive ontological innovation, and therefore we shouldn't believe that, and you were trying to be defensive against it. But I wonder what you think about the case where where the technology then fine grains. So it's both of which are supposed to be virtual reality technologies that are producing. Right, and you might even think that one's got like an inherent slightly different color cast to it, like digital cameras do, a slightly different coloring to it, or something like that. What should we say about the virtual frisbee that I throw to Nathan and Nathan throws to me across a system like that?
Yeah, thank you. So actually, this cross-play kind of question came when I was thinking about how this view, when I mentioned that the view is functionalist. So in that case, you can have, like the Beat Saber and Skyrim example. You have different data structures, but they are corresponding to the same virtual property type because they play the same functional role. But I think that Schubert, actually, what I don't like about this principle is that it's very rigid, meaning that unless he's willing to introduce a class of technologies or something like that, he's going to have to say that Apple Reality virtual properties are not the same ontological type of virtual properties as HTC Vive virtual properties, and that just seems crazy. So, what I would say is that it's more sensible to have an approach which doesn't identify rigidly property types to particular instances of data structures, right? You want to have a kind of algorithmic theory which can account for property types in terms of algorithmic profile, maybe. Does this, yeah?
Well, I think it's something like that. So some further abstraction needs to take place, I think, in order to avoid problems like that. And Dave's got his favoured version of that. No, that's grand. That's roughly where we're going. Okay, and we're pretty much on time, amazingly. So let's stop